Hello students, today we will discuss our first chapter for physics, that is electricity. This is the important chapter of class 10th physics. In this electricity we have first term, that is electric charge. What is an electric charge? Electric charge is the property of any object due to which it exerts a force on another object, and we have unit of charge is coulomb. We can represent coulomb by capital C, and notation for charge is Q. Q is the total charge. We have another statement, that is quantization of charge. It means total charge present on any object is always equal to integral multiple n times of basic value of charge in electron or proton. So n is integer values and E is 1.6 into 10 raised power minus 19 coulomb. For electron that will be negative, and for proton that will be positive. This is the quantization of charge. One numerical is here. How many electrons are there in 1 coulomb of charge? This is the basic numerical. So the solution is, we are provided with Q equals to 1 coulomb, and we know that E is equals to 1.6 into 10 raised power minus 19 coulomb. We have to calculate N. So according to quantization of formula, quantization of charge, Q equals to NE. So N is equals to Q upon E. So for N, 1 coulomb divided by 1.6 into 10 raised power minus 19 coulomb, and that gives us 6.25 into 10 raised power 18. So this is the value of N. Types of charges. We have two types of charges. One is positive charge and second is negative charge. When any object loses its electron, when any object loses its electrons, it will acquire positive charge. For example, sodium atom. When it loses its one electron, then it will acquire one positive charge. Mg, magnesium, it loses its two electrons, so it will acquire two positive charge. In similar manner, we have negative charge. When any object or atom gain the electrons, it will acquire negative charge. For example, chlorine atom. When chlorine atom takes one electron, then it will acquire negative charge. Bromine, when acquire one electron, also receive negative charge. So these are the two types of charges. Okay. So next we have some definitions of conductors and insulators. What are the conductors? Conductors are those substances through which electricity can flow, or we can say those substances which are having charge to flow. Those substances through which electricity can flow are called conductors. For example, all metals like silver, copper, aluminum, etc. Okay. Next we have insulators. What are the insulators? Those substances through which electricity cannot flow. Those substances through which electricity cannot flow are called insulators. For example, all non-metals except graphite, because graphite is a conductor of electricity. Even human body is also a conductor of electricity, as we know that electric current can pass through the human body. Next we have electricity can be classified into two categories. One is static electricity. Static electricity means electric charge remain at rest. So this charge can never flow. For example, charge on an ebonite rod or lightning which we see in the sky, etc. These are the examples of static electricity. We can use one single term, electrostatics. For this. Second term, we have current electricity. What is the current electricity? Current means flow. So in this, electric charge will be in motion. And produce current. Example, that current which we are using in our home. Electric current that we are using in our home. That is the example of current electricity. In this chapter, we will only discuss about this part, current electricity. In relation with this current electricity, we have another term that is electric potential. This is important part. What is the electric potential? Electric potential is one term that determines the rate or that determines the direction of flow of charge. This physical quantity will determine the flow of charge. And what is electric potential in actual? In a battery, for the definition of electric potential, let us understand the concept of electric potential. Suppose we are pedaling our cycle on a level road and we are fulfilling one condition that in every 1 minute we are covering a distance of 1 meter. Okay, and you can take 2 meter. So the speed of the cyclist must be constant to achieve this condition. After some time, there is this kind of flyover, but this condition must be there. In 1 minute, the cyclist must cover 1 meter with the constant speed. But if we apply the same speed on this part, then that cyclist will never achieve this condition. So he or she, the cyclist, must ensure that extra work is to be done by him or her. Extra work done by him or her to be there to achieve this condition. So that extra work done by that cyclist is known as his or her potential. As soon as the height increases, amount of work done by the cyclist will also be increases. So this is the electric potential or the potential of the cyclist. So in actual practice, this is our positive charge and there is a space around the charge which is known as electric field. Electric field of that charge, and we have a test charge Q naught. Test charge is always positive. So this is the positive charge and this is the negative charge. Now initially it is at infinite position, it is at infinity. This is the condition for now. So when this charge, while we are taking this charge from infinity to this point, there is no extra work done required like this till here. But as soon as we enter into the electric field of this charge, then this is the condition. So if we do not do any extra work done, then might be this charge will repel this charge outward. So we want to go to up, but due to this slanting, we are not achieving this condition. So in similar way, if we want to avoid the acceleration in this charged particle, that particular term is acceleration, because we do not want to change our velocity or speed. So we have to do extra work done while entering into the electric field. So as soon as we enter into the electric field of this charge, then amount of work done by this charge, is known as its potential, because we do not want any acceleration in our charge. So that extra work done by this charge is known as its potential. So what is electric potential? Electric potential is equals to work done by that charge. So V is equals to W by Q naught. And what is the unit of V? Unit of electric potential is volt. Unit of work done is joule, and unit of charge is coulomb. The second condition is, suppose if there is a negative charge instead of positive, then while taking this charge from infinity to a particular point inside the electric field, while entering into this field, then because of the negative charge, that test charge will be attracted strongly by this charge. So in that case, if we are moving like this, and suddenly after entering in this part, then our charge will go like this. So acceleration will be there, but we do not want any kind of acceleration. So in that case, we have to do the extra work done in opposite direction. In first case, we are pushing that charge inside the electric field of positive charge, but in case of negative charge, we have to pull the charge in the direction opposite to the direction of electric field. So this is the case. While moving down, the cyclist must have constant speed, but if the cyclist will not apply any brake, any kind of work done, then his or her speed increases. But we do not require, or we do not need any kind of acceleration, so he or she must apply the brake, or you can say that work done in opposite direction of motion. So this is the concept of electric potential, and here we go for the definition. So what is electric potential? Electric potential is the amount of work done by a charge while bringing it from infinity to a particular point inside the electric field. Okay, and how to define 1 volt? Potential, this potential is said to be 1 volt